So this question is asking to use a loop or mesh current analysis method to analyze this resistor circuit and calculate the power dissipated by the resistor R2. So this is our resistor R2 here. So we want to know what is the power dissipated. So we can use the mesh loop method. So in the mesh loop method, we can assign the mesh loop current. Let's assume that this is one current direction. We identify as the I1. And this is another cross loop, I2, and here is the I3. Okay, so that means we're going to write the KVL law for the mesh loop 1. So in this mesh loop 1, what we can see here, we can assign the current here. So in the I1, what is the current? The I1 is equal to 2 ampere. Okay, and this 2 ampere is flow through the R1. Okay, so there is a mesh loop 1. So in this case, what we can see here, we can find what is a mesh 2. Okay, so in the mesh 2, let's say we're going to start from here. So in these cases, what we can see, we have current flow to R3, we have this minus I2 R3. And then go to the V1. So go to the V1, we have a potential drop here, minus V1. Okay, and then go to this R3. R3, we have a 2 current flow. Okay, 2 current flow, one upward, one downward. So we have this I2 minus I1 times the R2, and this should give me 0. Okay, this should give me 0. Then we're going to write for the mesh loop 3. So mesh loop 3, we start from here. So we go to flow in these directions. So that means we have a minus I3 times R4. Okay, and then we have minus I3 times R5. Okay, go to this voltage source. This is a built-in voltage source. We have this 2 volt must be equal to 0. So this is the 3 mesh loop here. Okay. So in this case, what we can see, we can substitute the value for this mesh loop 2. So here we have R3 is equal to 1 ohm. So it's minus I2. And minus V1, we substitute we substitute this V1 here is 2 volt. And then here minus. So I2 minus I1. I2 minus I1. So R2 is equal to 3 ohm. This must be equal to 0. So here minus I2 minus 2 minus I2 minus minus, we get positive. So we have to multiply the bracket inside. So in these cases, we have minus 3I2 minus, we get positive 3I1 equal to 0. Okay. So now in this case, we have minus I2 minus 3I2, we get minus 4I2. And then here we have plus 3I1 must be equal to 2. Okay, equal to 2. Now we have equation 2 unknowns. So we can substitute the value of I1 here to find I2. So remember, this is the I1. So we can substitute here to find I2. So that means 4 I2 plus 3. I2 is 2 ampere. We substitute over here must be equal to 2. Now we can find what is the I2, right? So minus 4 I2. This equals to 6. 2 minus 6, you get minus 4. So your I2 is equal to minus 4 divided by minus 4. Then you get 1. Okay. So your I2 is 1 ampere. Okay. Now we need to find the I3. Okay, we in the mesh loop 3 here, the R4 is 3 ohm. So we have minus 3I3. R5 is 2 ohm. So we have 2I3. Then plus 2 must be equal to 0. So now we have minus 5 I3 equal to minus 2. So I3 is equal to minus 2 divided by minus 5. Then your I3 is equal to 2 divided by 5. Okay. So now what we want to know is what is the power, okay, dissipated in the R2, this one. So from this I2 we have two current, remember? This R2 here, we have I1s going down, and then we have this I2 going upward. So that means the net current of this, let's say net current is NETT, is equal to I1 minus I2. Okay, so we want to calculate the power. So in that case, power is given as P is equal to I square R, right? So I square is the net current, which is I net times the resistance R. So in this case, what is I naught? I naught here is equal to I1 minus I2. Okay, so I1 we know is 2 ampere minus 2 ampere. Okay, 2 ampere minus 1 ampere. So that means here we have this I net is equal to I1 minus I2, that is square times R. So we substitute the value. I1 is 2 ampere, I2 is 1 ampere, put that the square, and time the resistor is 3 ohm. So it's 1 square times 3, so you get 3 volt. Okay,